Now that we have some basic knowledge about the make files and kconfig system, let's try out some basic commands related to them. As a quick example, let's invoke make help from the coreboot directory. It will give us quite good overview what parameters make may take in coreboot. In the output, we will notice the platform, kconfig, toolchain and coreboot test targets. So now let's try to invoke it. I am already in the coreboot root directory, so I will just type make help. And now, as we can see, it printed out the possible make parameters. And as I said, these are divided into coreboot platform targets, kconfig targets, toolchain targets, and coreboot test targets. In the previous lesson, I have shown you how to invoke make and how to look for the parameters which make may take. Let's review now the most important commands from building coreboot perspective. Make, or simply make all, will start the building process of coreboot. Make clean removes the coreboot build artifacts. Make this clean is a harder version of clean. Besides the removal of the build artifacts, it removes the config files, cloned payloads and other build results. It will simply leave the coreboot repository clean from any result files. Make menu config updates the current configuration file utilizing a menu-based program. Make alt config updates the current configuration file using a provided .config file as a base. Make alt def config is almost the same as alt config, but with default answer to all new options. Make dev config creates new configuration file with default answer to all options. Make save dev config saves the current configuration file as devconfig. It creates somewhat minimal config because it skips all the default options. The reverse operation of the save dev config is alt dev config because it can recreate the full configuration file using the minimal config. Make cross-gcc -arc. It builds a cross compiler for a specific architecture. Make cross-gcc without passing arc will build cross compiler for all architectures. Make cross tools -arc builds the cross compiler with GNU debugger for a specific architecture. Architecture can be x86 32-bit or 64-bit, ARM 32-bit or ARM 64-bit, RISC-V, PowerPC, etc. One may use also the CPU's parameter to build the toolchain using multiple cores. It may save some time. Despite coreboot offers an option to build the toolchain, building the cross toolchain is rather time-consuming and may fail. It is rather recommended to use a Docker container for such case. However, if you have an exotic environment, you may try to build the cross toolchain yourself or enable the any toolchain kconfig option. If you are feeling lucky, maybe you will get through it, but do not count for any support in this case from the community. So, in order to avoid building the cross toolchain and save some time and possibly nerves, a Docker container is a recommended choice. We will not dig into why use Docker because it was already explained in previous chapters. So let us just execute the command to switch into the bash inside the Docker container. So this is the command that we will be typically using to switch into the container. And now we are inside the container. And as we can see, the coreboot directory with the source has been mounted inside the Docker container. Also, previous commands shall also work. As we can see, make help still works.